Okay, let's graph this. So what do I know? Do I have any, the first thing is C's or D's? I do. Which way have I moved? What and what? Left 1, down 3. So there is my starter. Left 1, down 3 is the starting of this. And the pattern over up 1 1 4 2 9 3. Is there any A's or B's that change that? No, there's not. So I just do that. 1 1 4 2 9 9 3. Okay, we've had enough practice with domain and range, right? It's good? All right. Have I moved my starter anywhere? Do I have any C's or D's? Nope. So where should I put my starting point? 0. 0, 0, the origin. Okay. Over, up, 1 1 4 2 9 3. Do I have any changes to this pattern? Okay, I have an A and a B. So what am I going to do with that on the chart? I'm going to take my X divided by -1 and 3 times the Y. Right? Because that's what we do with our B's, that's what we do with our A's. So this is going to all change to be negative. And 3, 6, 9. So that's my new movement. I'm going to go left 1, up 3. Left 4, up 6. There we go. That's enough points to say I know the pattern. Okay, ready. So that was what we did yesterday. Today we're going to graph the radical of the function that is graphed for me. Okay, what do we know about doing this? What do we know about square rooting a negative number? Doesn't work, right? So the part of the graph on here that will not work is that region right there. Do you know a number that is invariant if I square root it? So invariant means I'm going to take a number, and if I square root it, it's still the same. 1, and there's another number. There's 2 numbers in math. What did you say? 0. So the square root of 0, so when I have a height of 0, it stays at 0, and a height of 1 stays at 1. basically, I guess I should say this. In a transformation, I'm taking every point x, y, and this is what I'm doing in a transformation sense. I'm doing x, y is changing to x, comma, root y. I'm going to take this coordinate right here because it's 3, 4. Where will it go to now? 3, 2. Can I change my question? I think this original, I wanted to have arrows on it. Don't just add arrows because you're adding arrows. I wanted that as my original. Actually, in the next question too, I wanted that. So I had somebody on a test to actually just put arrows on for the fun of it because I did this example. I wanted this as my question. Okay. Okay, so now I want to know about this zone right here. Does anybody know what happened if I square root something like a half? Do you know what it turns into? You can do it on your calculator, the square root of a half. What happens to it? Is it like a 0.7 something?
Yes, 0.7.
Okay, so here's the thing. When we think of square rooting, you probably think that numbers go smaller. Is that something that your head thinks about? Like the square root of 9 turns into 3. That makes it smaller. But when you square root numbers that are decimals or fractions, they actually make numbers bigger. Right? This is bigger than that. So in this zone, I'm going to show you that my square root numbers are bigger than the graph. And then after this, the square root numbers will be smaller. And do you recognize the shape of the curve? And then...
So the 0.7 always, it will change the shape of the curve?
It's just that you need to understand that in this zone, when I square root the heights, they actually get bigger when I square root them. And then after that, the heights would get smaller. Okay, ready? Same idea. Which part of this graph will not exist if I square root it? This part down here will not exist, right? Because I can't square root that negative height. Which points will be invariant? There's actually 4 points that will not move when you go to square root them. Okay, I'm going to take a coordinate that I can clearly see at a height of 4, or I like heights of 4 and 9. Those are easy to move. So this coordinate, I need to move straight down to 2. And then I'm going to do the same to the other side. Okay, in the zone where the heights are between 0 and 1, my heights are now going to be bigger. So here I'm above the curve, and then now I'm below the curve. So in the first zone, you got to go over the curve. In the second zone, you got to go under the curve.
Can you tell me why you went out of the line when you went to the 2?
This?
Like, yeah.
I'm going from here through that point.
Yeah.
So from here to here, I have to be above where I was. And then once I hit here, I need to get below that. And I gave myself another coordinate to just go through. Yeah. Can I show you a common mistake? If somebody was graphing the square root, I've seen this. I've seen somebody doing this. What's wrong with what they did? That. I don't know. They swooped backwards, wrecking the domain. Okay? Because when I look at the domain, I might have asked you a question like this. When you looked at this first graph, actually, you know what? Here, I should make another question here. I'm going to go like this. Y equals x squared minus 4. Given the x squared minus 4, what's the domain of the square root of that? So what do you know about x squared minus 4? What do you know about it? What kind of shape does it make? You've learned how to graph lines? Quadratics, cubics, what is it? A parabola with a y-intercept of -4. Which regions can I square root? I can square root this, and I can't square root any of this section. Would anybody be able to figure out what these points are on an x value?
0?
The height is 0, but what's the x value?
Oh, okay.
2 and -2. So my domain is from -infinity to -2, and then I can square root from the 2 to infinity section as well. Okay, does that make sense? You're just saying, where can I square root? I can square root that zone and that zone. Okay. We're going to graph the square root of this on the second graph here. So I can't square root this little chunk. So I know that. Which points wouldn't change? There's actually 3 invariant points I can put on here. -4, 0, 1, 0, and 1.2, 1. These 3 points I can keep, and keep. What will you do with this coordinate, 3, 4? It's going to become 3, 2. And then do you remember the pattern? You're going to be a little bit over and then under. And then on this one, there's no arrow. Okay. Find the domain and range of this graph. Okay, people, grade 10. How do you graph this? How did you do this in grade 10? What is it? What shape is it when you graph it? A line. What do you know about this line?
So y-axis.
It has a 3 on the y-axis.
And a 0 on the x-axis.
Not quite. We know the slope. Do you remember mx plus b? What's the slope of this thing? 1. I'm just going to graph it lightly. Okay, now how do I graph the radical of this function? So this will not exist. I'm going to put a point there and there. And here I'm going to be over, and here I'm going to be under. Okay, so I just took it one step farther in that I made you think about what the graph looks like. So what is the domain? What's the only part of this that I could graph? So I had to stop there. So this is from -3 to infinity. And what's the range of this function? 0 to infinity. And that should always be, because when you square root something, you have to stop at 0, right? Okay, I'm going to change this question too. I'm going to change this to find the invariant points. Okay, what do you know? What's invariant? How do you know on a radical if it's not going to change? If what is happening? If what is 0? If the y is 0 or the y is 1? So if this function equals 0, therefore if x equals 4, but that's not my answer, what did I ask you for? A point. So the invariant point would be 4, 0. Or if y equaled 1, so if I add 4, that's 5. So there's an example of the invariant points. Okay, that was purely algebra. I'm just going to show you quickly. What do I know about this? It's a line 1, 2, 3, 4. I'm going to be going up 1, over 1. So when I go to square root this, what do I know? This won't exist. This point and this point will be invariant. And look it, isn't that matching? 4, 0 and 5, 1. They match. Okay, last chunk of the radicals and we're done. Okay, solve algebraically. So we did this in grade 11. Solving radicals. So I'm going to square both sides. Does that make sense why I'm squaring both sides? To get rid of the square root. We did that in grade 11. So x plus 3, because that will just cancel off, equals 4. And if I minus 3, my x-intercept should be at 1. Okay, now do you notice here what I did? What did I do from here to here? I moved the 2, right? So I just made an equation by moving everything to one side. Okay, what do you want to do with this? Where would you put your starter point? Left, right, up, down. Left 3, down 2. Over up pattern on this would be 1, 1, 4, 2, 9, 3, because nothing has happened differently. So this is when you just start to really hope that it does what you want it to do. What's the x-intercept of your graph? Okay, so algebraically, the 0 was matching the x-intercept, the root. Okay. Ready? We'll do this again. These are the same because they're both located on the one side, so we wouldn't have to move anything. How do I solve for this? What do you want to do algebraically first here? We're going to do a bunch of stuff. Which is going to go first? The 2, the 4, or the square part? What do you think? The 4. So I'm going to add 4. Now what? Divide by 2. Then we can square. Does that make sense? Remember those steps from grade 11? X plus 5 equals 4. If I subtract 5, I get a negative 1. Okay, let's graph this same equation. Everything was moved. Okay, I'm going to be going left 5, down 4. And I'm going to put my starter point. Left 5, down 4. Okay, here is my over-up pattern. And on this pattern, I'm going to times y by 2. So I'm going to need to do a 2, a 4, and a 6. So over 1, up 2. Over 4, up 4. Over 9, up 6. And did we match what we wanted to? What's the x-intercept? Negative 1. So what's good on that outcome on your test is if they don't match, you did something wrong and you know. You got to go back to do something, right?